Thank you, thank you, thank you. And again, I had a little late start there hitting the record button. So all that wonderful stuff from Mike Burkholz, for those that attended, totally legit, because we will make this available. Um, I appreciate the introduction, but just so everybody knows, as Pete Saronis and your facilitator for today, my sidekick, the wonderful Mike Burkholz from GSA, we try to convene this community of interest within the emerging technology community of interest, and our focus on IoT, smart cities, connected cities, intelligent cities, and our nation's most critical sectors. Today, we're going to talk a little bit about energy, but we're going to be tying in artificial intelligence because, as you will hear from our guests here in a minute, I don't think you'll find a more esteemed, forward-leaning, young, because I'm probably the dude on the backside of the back nine, as they say. But these folks who are innovators and come from all different parts, in terms of their journey, they're big fans of public-private partnership. So what we hope today, and I like to set the tone, is for everybody who did register and are attending, is hopefully educate you a little bit. We enlighten you, and then, of course, informing you on a lot of the material that we're going to cover. So without further ado, I will be the host, but we encourage you to use chat. And please, anything that we say, an acronym or where's that document, we will put a link into it because we will reference a couple, and we'll take it from there. So again, let's get into this. I'm Pete. I will be the moderator. I was the CTO at the U.S. Department of Energy for 8 of my 25 years in government. I run a company called Dots and Bridges, which is, you're looking at it. I like to connect those dots, whether it's people or information, build bridges, whether it's the information or, more importantly, relationship. And today I want to thank our guests. So with us, we have Abdul Mohammed, Director of Data Analytics at MISO. Maybe pronouncing that wrong, but I'm going to go with MISO. Nodding your head. Abdul, thank you. Yeah, okay, there you go. We've got Michal Thadani from the Rizomi, CEO. So you're going to get a picture of what it's like to build that company out, and a lot what they're doing. I'm saving all the fun stuff because I'm not going to read the bio. Seifer Gresham, co-founder of GridVolve. And if you Google him, he's doing a lot of things with a lot of people. And Charles Yang, who I just got to know in the last month and a half. I mean, Charles Yang, AI and supply chain policy advisor. That's what it says on your LinkedIn, Charles, who's come into government from that West Coast entrepreneurial startup community at the U.S. Department of Energy in the office of, and let me see if I get this right, because I was writing some of this down earlier, the Office of Critical and Emerging Technology. So without further ado, I've got some more context I want to set after we introduce our guests. So why don't we, looking at the picture here, start with you, Seifer.
Great. Well, first of all, I want to thank everybody for joining, as well as my co-panelists and the host especially. Thank you, Pete and Mike. As Pete said, my name is Seifer Gresham. I'm co-founder of GridVolve. And at GridVolve, we're really focused on accelerating the transformation of the electric grid industry. And we do this through leveraging AI and other tools to help ISOs collaborate, strategize, align leadership, prioritize impactful projects, and then push that out to the market to drive the transformation through marketplace of innovative companies, that startups, venture firms, leading think tanks, and national labs. And all of this will enable the grid to transform and drive a faster, more reliable and sustainable future for the electricity grid market.
Thank you. And before I move to Mish, nickname Michal, but he said we can say Mish, is, thank you, Seifer. I mean, again, for our guests, I mean, I hope you all can chat among yourselves. There's some amazing federal thought leaders on here. I saw Jay Huey just joined, and I mentioned my colleague Vicky, and so many folks, Tim Gilday and Tiffany Chu. This grid concept, or should I say topic, we use it every day, whether you realize it or not. And when it goes down or it's subjected to some cyber or physical, vulnerability, that's the real impact. And that could be through environmental, natural, or bad actor. And that is something we're focused on, and how AI can help move that needle. So, Michal, the floor is yours.
Yeah, thanks so much, Pete. It's a real pleasure, as Seifer said, to be here with you all. I'm actually sitting in Washington, D.C. and have, for the last 10 years, really been sitting at the intersection of energy technology and policy, mostly on the state regulatory front, but certainly have some federal nexus as well. So I'm excited to sort of give you a sense of what Rhizome is doing today. As Pete mentioned, I'm the co-founder and CEO of Rhizome. We're an AI software company looking to help bring intelligence to identify grid vulnerabilities from extreme weather threats, and then ultimately optimize utility capital plans to enable a greater resilient future as these extreme weather events become more intense and severe. And just to take a step back a little bit, my history has really been in the energy generation space. The first company that I started was a community solar company, so I was focused on building energy resilience from a distributed generation standpoint, and worked quite a bit on local policy for grid modernization in DC. I was about 6 years ago very intrigued at all the various applications and use cases around AI, from energy efficiency, efficiency in buildings, to integrating distributed energy resources, to things like dynamic line rating. There are lots of different use cases that can help enable this energy transition. And again, I wanted to be at that intersection of new cutting edge technology and policy that could help this technology scale within a traditionally hard to innovate in sector. So I ended up launching Rhizome a few years ago to really bring AI at this intersection of extreme weather threats and utility infrastructure to really understand what are those optimal paths for investing in the grid of the future. As we try to transition this grid to a cleaner generation sources, we of course need to rely on the reliability and resilience of that grid in the process.
Wonderful. And I apologize for not pronouncing Rhizome properly the first time. It was, again, one of those like, Pete, come on, you told yourself 10 times to ask Mish how to properly say it, but my bad. Hey, folks, before we jump down to Charles, look, I'm looking at something that I'm just going to hold up. It's called AI in the Grid. It's a one-pager. I believe in, facts tell, but stories sell. We may use some jargon today and buzzwords like generation, distribution, transmission. Just know this: when you flip your lights on in your house, a lot of stuff is happening in real time. And as we move into this world of cloud and AI, for my technologists on the call here today, there's opportunity to help with this movement. This is not about the U.S. Department of Energy. It's about the energy sector. The U.S. Department of Energy is the sector risk management agency for the energy sector. So if you're going to be in Dallas next week with a lot of us, you'll hear a lot about grid vulnerability and opportunity to create a smarter, more intelligent grid. Somebody was just saying something. No? Okay. Let me jump down to Charles, because before Charles gets in, the White House recently put out its updated critical and emerging technologies list, which isn't a bad read, everybody. And it gets updated. His office is titled that. Charles, let's talk about you, your passion, and what brought you to DOE a little bit.
Yeah, thanks, Pete. And thanks again. I echo my thanks for everyone for joining. I came from the startup world and I joined DOE over a year ago now, and was really because I was excited by the work that we were doing with Inflation Reduction Act and bipartisan infrastructure law and all the new things that DOE is doing. And since the time that I've joined, I have learned so much more about what DOE does, far more than I thought I knew, than what I knew at the beginning. So with respect to AI, I know we're going to talk about AI in the grid in a moment, but I want to zoom out, because at DOE, we're excited about what AI can do as a transformational technology for not just the grid, but for how we think about energy systems and scientific discovery and our national security mission. All three of those are things that DOE touches on. So recently, we put out an AI for Energy report that covers AI applications in the power grid, but also across the clean energy economy around transportation and buildings and agriculture and manufacturing. And recognizing the kind of opportunity in the moment before us, with how quickly AI is changing the way that we think about science and energy. We recently released our DOE's Frontiers in AI for Science, Security, and Technology Initiative, or FAST. This is kind of our proposal for how the DOE and our 17 national labs can come together to provide a national AI capability for the public interest to build the world's largest integrated scientific AI systems to enable our power grid, but also to drive scientific discovery in a variety of domains, help us realize more abundant battery materials, maybe even endless fusion energy, and the next cancer discovery drug. And we've already seen early successes from our labs on all those fronts. So very excited to be here and talk to you all about the grid. But I think here too, we're excited about all of the ways that AI can be transforming our landscape.
Wonderful. And I was just doing my thing. There's a one-pager that everybody, if you go to energy.gov and wanted to download, the Frontiers in Artificial Intelligence for Science, Security, and Technology, FAST with 2 S's. What a story. It tells you one from, how our national labs and our industry partners and our technology transfer and the emerging tech. It's a lot, folks, but isn't that what this is about? The mission of the agencies you're either calling into or you work with, to understand there are people like Charles and our colleagues here are working together to move that needle. All right, let me get to Abdul, folks, because if you're familiar at all with the geeky side of how the grid is monitored and run, and it's a very old, antiquated, why we're trying to talk resilience. You know, Abdul, if you can kind of paint that picture, in addition, a little bit at your wonderful background about the role that your company plays in keeping those lights on, which is 15 states and parts of Canada.
Absolutely. Thank you, Pete, and thank you, everyone, first of all, for having me. Currently, I am the Director of Data Analytics at MISO, as Pete introduced me. To be honest with you, the story is, 14 years ago, if anybody would have asked me if I would be even in this industry or do what I am doing today, which is forefront of this emerging technology revolution, I would probably have said, no. When I was doing my master's, I wanted to go somewhere close to Silicon Valley and was really passionate about chip design until an internship happened at a local utility in Chicago. And that changed my mind because I saw the opportunity of how important this is for United States, how important this is for the mission of what it provides. And when I joined MISO 12 years ago, I've played a lot of different roles in engineering, in operations. And if you think about it, really the way we classify that is an air traffic controller for electricity, right? MISO does not own any assets when it comes to transmission and generation, but what we do is we ensure the reliability of the high voltage transmission system, and we operate one of the largest markets in the world, which is very diverse geographically, politically, and also in the sense of just, Pete, you talked about the aging grid, the system design. So big reason for what we are trying to do today is at MISO here is, and my job is because of the reliability imperative that was rolled out, which is nothing but dealing with some of the things Charles, Siffer, and Mish earlier pointed out, which is dealing with more uncertainty and variability. How are we going to manage the fast and rapidly changing resource fleet across the US footprint? How are we going to deal with the aging infrastructure from a transmission perspective? And then how are we going to be also the element that I would like to add to what the panel has already said is our workforce. The type of workforce that we are seeing across the industry, especially we have seen that at MISO, is not the workforce that we're going to be able to get in the future, who were experienced, who had decades of knowledge about the system, the grid, and what they brought to the table was that institutional domain knowledge, which is where I feel the emerging technologies like AI, machine learning, deep learning can actually help us mitigate the challenge of even an evolving workforce. And the workforce that we have today wants to solve problems very differently from the workforce that we had maybe when I joined this industry. A culmination of that has been leading to us partnering with certain folks here on the call itself, as well as outside on doing some remarkable stuff within the RTO ISO space, where we are really looking at how we can set up a strong foundation that helps us use a lot of these AI technologies much better in the future.
I appreciate that. And again, folks, chat, ask questions, direct them at some of our guests if you have a specific, but I'm going to summarize before we jump back here in a CIFR, and that is who you're hearing from are the folks that if you are in the DMV, the DC, Maryland, Virginia area, or just in general, we in DC do a lot of policy development. We have executive orders coming out. We have OMB memoranda that just constantly are telling agencies what needs to be done. If our guests today, meaning our registrants, can understand, we've got a United States Department of Energy stakeholder. We've got an individual in Charles who kind of knows where it's going. And yes, there's funding, folks. For all of you, where's the money behind all this, right? There's always funding. And then it's how do we pull together the people to mind meld and discuss and really understand what it takes to be, in that if you're in generation of energy, if you're going to be in transmitting it. Think of it when you're on the highway and you see all those power lines. That's the transmission network. Generation is when you see a power plant of some sort, coal fire, whatever it is, nuclear reactors generating electricity and power, and then ultimately it's distributed to your home. I'm Pepco. So, they do something at substations in the local area. So it's very interconnected. And I want to say, again, for the IT people on here, we may reference operational technology. So when I think of, the AI component, or Rhizomi is, doing stuff with a software platform for metrics and analytics, make no mistake, this is an IT discussion supporting one of our sectors that is becoming more and more integrated with the stuff that is sold to and into the government quite often. So, Seifer, let's jump it back to you, right? Like, you're at the forefront of knowing what cool technology is out there. You talk about driving growth and cultivating partnership and, grid operator engagement. What's something you'd want to tell this community about, what needs to be won, what's the challenge, and where's our opportunity? And then we're going to go to each of you and ask the same thing, and try to keep it to a couple of minutes so we can kind of dive into some of your other personal background information.
Yeah, I think Pete, it's a great question. For the community, I think the majority of the conversation around AI, especially if you read the news day to day, has been around load growth. Okay, we have, the like data centers could consume more than 9% of US's electricity generation by 2030, doubling what it is today. Just in the past year alone, I mean, we went from 19 gigawatts in data center, load to this year, it's estimated to be at 21 gigawatts of load from data centers alone. And AI is driving that. So we hear that story. But what often is so lost in the conversation is the impact AI is having actually on the industry, the electric grid industry itself, and the opportunities that could be there to think about the process of planning net new facilities, permitting and siting of new power gen facilities, and speeding up that process. We know it's a highly regulated industry that goes through quite a bit of diligence every time a new power plant, power gen facility is proposed. Putting net new, transmission lines takes a really long time. And that's because you have federal, you have state, you have local regulations, not to mention the actual companies that are going to be building them, having to all come together, agree on the path, and work through it. Well, AI can help with a few different angles around this. And something I want the community to leave with is that AI and collaboration tools are really going to be at the forefront of in near term speeding this process.
Okay. Well, no, thank you. And I want to jump down to Charles, because Charles, again, if anybody goes to the website and looks at what does the Office of Critical and Emerging Technologies do, I look amplifying expertise in capabilities for critical science, energy, security challenges. There's a cybersecurity component to this, folks, right? Coordinating the equities and working on partnerships. You mentioned a number of documents that are wonderful reads. Again, folks, if you didn't catch those, and I'm asking my buddy Mike, if you haven't already done it, Mike, do that. There's an AI for energy that comes from the national labs. There's an AI for energy, and these are dated in April of this year. Charles, you're talking to a community of people that would probably die to meet you and have a meeting and want to talk. What is your message, and what are you feeling very excited about in terms of this opportunity with AI, especially?
Yeah, thanks. And I'll echo kind of Seifer's point. I think people have been talking a lot about load growth, for instance, right? And the data center build out. And a lot of that is driven by AI. But we actually see this as an opportunity in multiple directions. It's an opportunity for us to tie advanced clean firm energy like advanced nuclear or geothermal, and use the high willingness to pay of these data center operators to actually help us deploy first of a kind, nth of a kind clean energy technologies onto the grid. It's also an opportunity because it's deploying more AI models into the world, right? And I think that's something that's really underrated, which is that AI, while driving load growth, is also an opportunity for us to meet our energy goals and promote a more resilient grid. So some specific things we're excited about. So Seifer, just about riff off what he said, talked about permitting, which is one of the key timeline drivers for how long it takes for us to deploy clean energy. DOE announced a $19 million effort to build large language model tools to support federal environmental reviewers and eventually state and local environmental reviews and permitting as well. And so we've already started that effort underway. We had a hackathon in San Francisco a couple of weeks ago where we had OpenAI and Lower Carbon invite us out. They brought together 100 hackers and software engineers to work on some of the data that we put out. We are already working across the interagency to put the tools that we've developed internally with Pacific Northwest National Lab in the hands of federal environmental reviewers across different agencies that review these permits, as well as, of course, within DOE. That's still very early days, but it's something I think we'll see pick up over the course of this summer, and we hope to have more to announce on that specific front soon. So that's some of the things I think we're really excited about. Go ahead, Pete.
Well, no, please. And again, this is a riffing conversation. Tell me to shut up and say, Pete, I wasn't done yet, man. No, I see Yuri has a question. So I'm going to ask my guests, please, if you can, if there's a specific question you want to respond to, just use the chat and reply to everyone. That would be fantastic. But Charles, you're talking there's dollars. You put dollars. I say you follow the money, you meet the mission, opportunity knocking, folks. Mish, when I look at Rhizomi and see an AI-powered software platform that helps, and then this is where I think it's unique. Electric utilities identify vulnerabilities from climate threats, hint, hint, Tiffany Chu out there, quantify risk at high resolution, and measure economic and social benefits of grid-enhancing investments. And I know my colleague Paula Gold-Williams is loving that. You make software that's helping support something we rely on every day. Talk a bit more about what you love about this platform and how it's benefiting others.
Yeah, absolutely. And where we designed this platform is really for operational use cases of planning, and this is long-term planning. How do you optimize the capital plans that are going into utility infrastructure? Typically, for an average distribution utility, say CPS, like Paula was at, they're spending hundreds of millions of dollars a year on CapEx to improve the reliability and service to customers at the end of the day. So the question is, how do you optimize those capital plans to also optimize for reducing the failure from extreme weather circumstances? And I just want to break down the energy system just very briefly before I talk about where Rhizome is actually coming into play. So it all starts with generation, where you generate the power at coal, nuclear, wind, natural gas plants. You then send power through an interstate transmission system to the substations, the high voltage stuff, and that's where the bulk power system is managed, where MISO is focused, and Abdul. And then lastly, it gets into a substation for local distribution companies to actually get that power from high voltage, step it down to lower voltage, and actually distribute it among communities within states. And this is really where Rhizome is focusing on, is on that local distribution company. How do you actually ensure that the poles and wires that are connecting all of our communities together actually stay resilient with regard to extreme temperatures, high winds, storms, so on and so forth? We just had Hurricane Beryl just come through Houston. 2.5 million people lost power, and the restoration time, I believe, still isn't even over yet, and it's been almost 2 weeks. So what we're really trying to understand, first historically, is where have extreme weather events occurred and what have been the failures at high resolutions on every single asset. So we can do this analysis all the way down to the very last pole that you might see out your window right now. You can then understand, given a likelihood of failure from those extreme weather conditions, using climate data. And there's a whole other practice of AI that unpacks how global climate models and the data that is produced through those models can be downscaled at high resolutions for specific geographies, so that you can anticipate for any given region what's going to be the extreme weather events and the frequencies and intensity that occur over the next decades. So a 1 in 10-year storm today in the Northeast is actually likely to be a 1 in 2-year storm by 2050. And that's kind of a scary thought, because right now utilities are typically planning according to the current baseline or historical patterns of weather events, where they should really be planning for what's happening in the future. Capital plans typically have a shelf life of around 50 years. You have capital investments that last, infrastructure lasts a very, very long time. So what we're effectively trying to do is match up the capital planning profiles for many types of investments, including undergrounding, replacing aging assets, replacing and upgrading transformers, increasing the capacity of lines, and align that with a 50-year future risk profile. Again, getting to high resolutions so that the utility, when they used our software, can see these analytics at high resolutions on every circuit and even on every line segment. That way you can make the most optimal decision at every location.
Sure. Let me take that and jump down to Abdul. Abdul, you're a grid operator, right? You're a young guy too, and you're not saying, "Hey, what we have is fine. If it ain't broken, let's not try to fix it." We are an IoT community. We are a zero trust community. We have data centers. We have the cloud. There is a way of keeping the grid up, and I'm a proponent of, there's some stuff that never needs maybe an IT integration, but when I look at some of the challenges in the workshop document that Charles referenced as well, data quality, availability, interoperability, and of course cybersecurity, how do you embrace innovation as an operator while at the same time try to convey to the old school folks that this isn't a bad thing, because we need to do what Michelle is talking about, Misha, is we have to be prescriptive and predictive in what could happen. Abdul?
That's a very important question in the context of today, Pete. And it starts with setting up the right ambition and strategy. As an organization, as a US grid, if our strategy is that we have to be ready for the uncertainty that Mish and Safer and Charles are talking about, right? It is imperative on us that we start working towards that future. So first, it's creating that common goal, because then I can get the old school to say, isn't that our common objective and goal? So some of the initiatives that we have done, that's the approach that we have taken. Of course, on the change curve, you have all the spectrums, right? Like, you're going to have people who are going to be early adopters. You're going to have people who are going to challenge why the change, why is it needed? It's getting that common why understood, and then from there envisioning how we can get to it together. And if the other thing that the utilities have to understand, Pete, in the context of your question, is we do not have answers necessarily to all the questions. Where do we need to pull in partners? Where do we need to pull in people from the government, from the policy making, from the technology building, right? Like, let's pull the right partners, have a common problem that we want to solve and address. And in this case, I'm going to make one, it's uncertainty. The uncertainty and how we can predict it with the changing fleet, with the ever-growing load demand, right? With the policies, fluctuating, where you have a west and east kind of going more faster than maybe the rest of the company. And then the impact of the events we're seeing. The kind of events Mish is talking about are more frequent now, is what MISO as a grid operator is seeing, right? Like, we are seeing more and more of these events. So when we make this business case, Pete, to the IT, to the infrastructure, to the cloud folks, to the security folks, it's about creating the right balance, working with the right partners, understanding that this is the problem that we are trying to solve, because if we don't, this is what we are going to see more in the future.
I love it. I love it. Seifer, I'm going to come up to you here. And again, now it's a matter of, I might just say, fellas, you have a comment. Tiffany Chu put a great question out there, and it's kind of where I was going. So please take a look at, again, the chats, folks, and feel free to comment to our guests. Look, when I think of, Seifer, the AI for energy opportunities for a modern grid and clean energy economy document, great read. Thank you, Charles. And this is, again, the AI component. A lot of people have said to me, Pete, climate change, where's the money in that? And, AI, we're still trying to figure it out. And, well, I'm looking right here. If I were to say there were bullet points out of this document, it hits grid management, energy efficiency, but it talks about renewable energy integration, not replacing fossil fuels, but renewable for what we like to call resilience, folks. It's not the same thing as reliability. But I see optimizing the integration of renewable energy sources. Tiffany, great question you asked. Forecasting tools. This is summary of the document the government put out, and we're seeing here on this call, people are doing this, but forecasting tools and helping identify priorities for those renewable energy projects. Seifer, the question is, knowing all this and this great information, and the trains left the station, what are you hearing and seeing from these communities, governments, startups, integrators? Are they embracing it? Or are they kind of like, one thing at a time, when I don't think we can be serial in this kind of dialogue?
Yeah, I think it's a great question. And so, one, I want to call back on Mish on talking through the different layers that operate within the grid. And also, and there's different timelines of integration across the grid. So you have some groups that can move things forward when you have microgrids, when you have specific communities that that can invest faster, further. They can leverage funding from like Department of Energy with siting permitting acceleration through this program called Energy Works to actually accelerate some of that the implementation of more renewable strategies. But I think like if we take it back up one level, so where we are today is, you know, the grid, at least at the end of this past year, was I think about like 1.1 terawatts, and where we need to go with intermittent resources and then firm demand fixed resources, we need to have, I think it's like, and Charles, you might need to help me out here. I think it was like 2.5 terawatts. So we need to add a significant amount of demand onto that. We need to add about what is like a terawatt of renewables to get to that clean energy, and then we need to have firm fixed in there as well. Again, I don't have the exact numbers in front of me, but so there's a significant amount of investment going into this. And so from the startup community, you have from lab bench going up to commercialization, a significant amount of energy from ARPA-E, from SIBRs, but then you also have venture capital firms that are deploying money into these early bets. And so that's not only intermittent resources, solar, wind, but it's also like small modular reactors and other technologies that are being invested in. Now, if you go to the other side of the equation, and I think this is where I get excited, is we got you know, colleagues that I work with, like Abdul at the independent system operators, are trying to plan out the future demand of when these net new technologies are going to actually be at utility scale levels that they will be able to call upon those resources to meet the demand, the load growth demand. And so, you know, I think the real opportunity is getting the different stakeholders together. So, for example, having Abdul talk with some of the startups to understand the reliability imperative that MISO has.
Can I jump in for a minute? And that's where I think what you're getting at is this is where government, industry, academia, those again on the call, this is open government in action. If we're not collaborative, transparent, or participatory, how are we moving the needle? I see my colleague Ivan just joined, another grid operator dude who understands how it works. Charles, can you comment on some of that? And then we're getting into this, how do we move that needle? Policy documents, injecting IoT devices that don't even have a standard yet, but could work. How do we work in that collaborative way, but also try to get this stuff commercialized?
Yeah, definitely. And you've seen a lot of the funding come out of DOE in the past couple of years through the Inflation Reduction Act is really helping build out this bridge to commerciality where we have our Office of Science, the national labs, and the SIBRs. We have our applied R&D program offices. And now we have this whole new part of DOE, our Undersecretary of Infrastructure, that is giving out hundreds of millions of dollars of grants, loans, and tax credits to support not just, you know, startups, but even startups that have matured and are now ready to build their first of a kind factory. We're also supporting investments in our grid supply chain, for instance, and ensuring that we have a reliable, resilient grid requires reliable and resilient supply chains as well, right? But to the point about partnerships, I should first caveat that DOE is not a regulatory agency, and a lot of that comes through FERC. Where we support is both on the funding side and also, of course, on the coordination through our national labs. So I know Argonne National Lab, for instance, is doing a lot of work around weather forecasting with AI models. And they're also collaborating closely with NOAA, which is the federal agency for that, but also with a lot of the stakeholders who are impacted by changing extreme weather, not just on the grid side, but even in the communities themselves, right? So it's certainly always hard, right? Coordination is the problem of our time, or at least in government, right, to coordinate across all these different stakeholders. But it's one where I think we have a lot of new tools in addition to the existing tools, and including our national lab, which act as, I think, great hubs across the country to do this kinds of coordination work with regional stakeholders. And of course, FERC, who's kind of a sister, and EIA, another sister part of DOE, where we can kind of coordinate and have the fulsome picture of the energy landscape. But that all, of course, requires conversations and groups like this where we can talk with folks who are implementing and who are working in industry to kind of solve these problems.
Love it. Misha, I'm going to jump over to you. Let me just do what I love to do. And that's, again, for our IT people on the call here, advancing national security, attracting and building a talented workforce, harnessing AI for scientific discovery. This is the value proposition if you make products today. IoT devices, they're part of the grid. We all know the term zero trust. The government is adopting zero trust strategies. Let's get stuff out there and collect data at the edge. Let's bring it in. Let's make sense of what we're doing till we can save lives, right? So that people don't starve or are frozen in a home where there's no heat. This is how we address these challenges. Mish, you're in the middle of this AI. I mean, and you're combining it again. We've talked about. What are your thoughts on what we're hitting on in terms of collaboration?
Yeah, for collaboration, it's multifaceted, and there are lots of stakeholders at play that can really advance AI in the sector. So I'll start with government for now. Not only the federal agencies where legislation through the bipartisan infrastructure law enabled billions of dollars of investment to go into infrastructure to make things more resilient, but also in technologies that can accelerate that resilience as well. Advanced modeling technologies is one of them, but you also have things like microgrids and battery storage that are funded through federal money that can really increase the resilience of the grid in new and different ways, providing a new cost benefit that might be improved over some of the traditional legacy investments. And so we are ultimately a provider of AI for enterprises. So anything in the federal government sphere that can help enterprises adopt this technology, either through direct funding or maybe even standards, will help accelerate AI within these sectors. Related to other government aspects of things, the states also govern a significant part of the grid, right? Each state has utility regulators that are in charge of understanding what are the costs and expenses that utilities make that are actually worthwhile for delivering values to ratepayers and utility customers like all of us. And ultimately, working with the regulators very closely can really help educate them on the value and benefits of the new technologies that utilities are ultimately going to be adopting. And again, just help accelerate that process. And then you have lots of other stakeholders from the nonprofit and community space as well. We actually do have community partners that we work with closely. At the end of the day, we collect data from individual communities, geospatial data sets from data providers, but ultimately local communities are going to have a really large say as to what models can actually be used. How do you bias correct for some of these models? And then ultimately, what sort of decisions are going to be made as a result of these models that are going to actually influence the communities themselves. So when it comes to making decisions on the grid, environmental justice data and social equity data is actually really important for what we do. Because ensuring that vulnerable communities are protected against the growing threats of extreme weather is critical. And so one of the things that we're doing to help address that is bringing in state level environmental justice data at the census level. So that way the utility partners with community input get a sense of where are the underserved communities, how can we demonstrate the vulnerabilities across the spectrum of vulnerability, and then at the end of the day, how can we demonstrate that the benefits of the investments are actually going to the areas that are most disadvantaged.
All right, Mish, you get like a gold star, not the, because everybody's getting gold stars, but environmental justice. Mike, if you can put up the Justice 40 link about what that's about when Executive Order 14057 came out, which is really one our government audience probably has read. But again, it goes back to Charles's comments and others. These are folks that are reading these policy recommendations. It's not just about climate change. It's about environmental justice and having those equities and who gets what first. I mean, there are disadvantaged communities in this country that still don't have, internet access. We like to throw that phrase around. Well, facts tell, stories sell, folks. We're lucky here in the East Coast in Washington, D.C., but environmental justice is a term we're hitting on, resilience versus reliability. And of course, there's no shortage of cool tech out there, but when Colonial Pipeline hit, folks, Executive Order 14028 came out. And operational technology, in my view, is introduced into the minds and the ears and the eyes of people and said, well, what is that stuff? Well, it's the sister of information technology. And without that, we don't have power. Abdul, you're hearing this, right? And by the way, thank you, Mish, for that. And again, there's that AI feeling and flavor to this. Abdul, regulators, the Federal Energy Regulatory Commission, folks, FERC, NERC, the North American Electricity Reliability Corporation. All right. FERC and NERC exist for a reason. They work with federal agencies, but collaboration. You're again a gentleman in a community with some old school thinking. but also the opportunity. What can government be doing more in your minds to help your industry adopt some of this promise of the future?
Uh, I think it's the ongoing dialogue. It's the ongoing understanding of the actual issues and challenges and opportunities that we have. And I think I'm going to put it this way. We've been talking about AI and tools of adopting that. But a cool way of adopting that could actually be using the technology itself to see what it's telling us. What is that data telling us? What are the models telling us already? What are they informing us about load growth? And then going back and seeing how close were those models. So that can allow partly the policymakers and the government, Pete, and others to kind of trust that, hey, these type of emerging technologies and methods actually work. And then, like some of the others were saying on this call, work, collaboratively on how can we, move forward in this environment of like, yeah, everybody wants to, for example, move to the cloud, but how do we make that happen securely, reliably, and do that? For me, it's not like, yeah, you got to trust and then adopt this technology, but I think you can use the technology itself and the various models that are already running in the country to see how the rate of change of pace is happening, and then work with the utilities, work with the grid operators on what could be the best plan that could help at the end of the day for our communities, right? Like that is what we make as our mission, Pete, is the close to 50 million customers we serve across 15 states and a province of Canada. So we work with a lot of different state regulators, policymakers, and we have started using this methodology to really take them the data and say, hey, here's what the data is telling us. Here's what the study is telling us. Here's what the model is telling us. And to some of the points others are making, I would wrap it up with this. That now allows you to even more trust. Like, okay, this is the type of approach. This is the type of changes that we have to adopt, and we have to open up the policies to be able to do that faster.
I love it. Mish, are you good with the comment you had asked me about getting unmuted? Can you hear us? Can you say something? Just
Yep, all good over here. Thanks,
okay,
Pete.
got it. You got it. Hey, let me go to some of the feedback I'm seeing here on the right hand side. And yes, we are recording this, and we hope you all will watch it because it will be posted later. When I referenced earlier, the critical and emerging technology list, which was not published by DOE, even though Charles works in that shop with that title. This is a report in February that came out and had members from all over the federal agency. I just find it cool and interesting. But, of the 18 that are listed, I mean, artificial intelligence is indeed one. Clean energy generation and storage is another. Advanced gas turbine engine technologies is another. You see where I'm going with this. Directed energy is another. And then data privacy, data security, and cybersecurity are among those. So, folks, just to remind, DHS, they say there are 16 sectors in our country that are most critical to the quality of life, to communities, to people. They are the humanizing sectors that what we're talking about today. And you could fill in the blank: medicine, agriculture, food. These products and tools and things can apply throughout. But I just want to comment on that. And then look, we got 12 minutes. And here's where I'm going to just go back around and, within reason, right? Seifer, what are we not talking about that you want to convey? And then let's go down to Charles, and then we'll go Mish and Abdul, and hopefully we can fit that in and maybe hit on one more point. So Seifer.
Yeah. So thanks, Pete. The lot of really, really interesting points today in the panel. And one, I just want to call back to Mish and Abdul on the climate justice and the role it plays. And also one thing I want to challenge everybody listening here to think about is how do we create opportunities to raise up the voices of those who don't often have a voice at the table. And I think that we can do that through data transparency and through a lot of the work that like Rhizome is doing at the really granular level. But it takes we need to go like a step even beyond that, right? We need to make sure that those individuals are then brought to the table, either different nonprofit groups, different stakeholders, through what we have is this great experiment of democracy to make sure that their voices and their experiences are heard about why an investment in that community is going to see net new economic growth for a disadvantaged community and how important that is. So one challenge to the entire community that's listening and also to my fellow panelists is we always have to embed that into our missions. Two, and this is actually a tangent of this, but it's how do we cross collaborate amongst all the different stakeholders on this call? And it's something that we're working on extensively at GridVolve. It's like MISO has unique data sets that they control. Rhizome is building some really significant power tools. Department of Energy collates a lot of different data sets. We have FERC, all these, and they end up having different structures. And so one of the key pieces in the near term that I want to bring the community together around is how do we create interoperability between all of our systems so that we can forward some of the reliability, resiliency, and most importantly, sustainability of the grid of the future. And that's going to take a lot of time, effort, and energy amongst all of us to be at the table together talking about, you know, where our data is, what does it look like, and then, but how do we do it securely?
Well, let me just say for the record, everybody, when I hear that, I mean, I'm hearing as a former Fed, like easier said than done. Not everybody's going to be at the table at the same time, but it is needed. And I think what we're seeing, and it's back to some of the comments, you know, distributed energy resources, DER, the way we burn coal and extract natural gas today, it's a process. But when we're talking about, we want this resilient, reliable, if God forbid something happens and there's a natural disaster in our own communities, folks, when the power's out, everything stops. Picking up your kids, what am I going to do for dinner? And yeah, it might be cool to have a snow day, but I want my heat back. That's what I feel, Seifer, you're getting at, which is these conversations can happen, but where's the action? And I commend the federal government, the entrepreneurs, the spirit, but there is still regulatory issues, policy issues, and of course standards. And we have to be kind of moving in the same direction versus saying, let's get to the table and whiteboard it and have a jam session. And then it's just that it's parallel focus, not as much being serial. I appreciate that. Charles, thoughts?
Yeah, just say the way I see where we are right now, it's just an incredible moment.
You're a little low. Can you speak up a little more, bud?
Yeah. It's just, I was saying that the way I see where we are right now is just an incredible moment of transformation and opportunity, not just because of AI, but because of where we are in the clean energy transition. We have to, President Biden has set the goal of 100% clean energy by 2035. That is like not that far away to completely rehaul how we think about the grid and the very electricity that we get every day. And then 2050 for net zero, that's reshaping essentially to transition to a clean energy economy. So that's why I'm so excited to be here at the Department of Energy. It's why I'm excited to be working in this space of energy and grid and AI is because there's so much happening that it needs to happen, right? When we think about the things that are going on with climate change and all of the outflow of climate change from the need for greater resilience in the communities impacted. So all this to say is like, I'm personally very excited. And I think, very excited to be in this intersection. And I hope folks here on the call are also just as excited about all the different ways that we're working together to address these kinds of problems.
Thank you. And thanks for joining the Federal Service, pal. I know it was a big lift probably, from the West Coast, but I know that Helena is loving what you're doing. Shout out to Helena Fu. And, Charles, you're saying the government can only do so much, but there's clearly funding and meeting mission with passion is definitely something I could feel in your commentary. Thank you. Mish.
Yeah, so where I want to focus my attention on for this closing is really around how do we move the ball forward faster on climate resilience and adaptation, broadly speaking, not just in the energy sector, but broadly. We just had the hottest year on record this year, right? So far, it's looking to be the hottest year on record. We're seeing the impacts of that. We're seeing the impacts of storms that are changing by nature and having different impacts. And I think that there are a lot of indicators that we're on the right track. You have the federal government that has started doing climate adaptation and resilience plans for each of the agencies. But when you look at the utility sector where we operate, roughly 10% of utilities coverage in the U.S. has done a climate change vulnerability study, right? So it's going to take a lot more conversations, a lot more initiatives, and a lot more people getting around the table saying, we really need to just advance the ball on climate resilience and adaptation to actually put forth different efforts, both funding, programs, pilots, in order to actually meet the current need, which is that climate change is impacting us way faster than we think. The last example that I give is wildfires have historically been, or rather are, the largest threat to the electric sector today. We have utilities going into bankruptcy because of wildfires. And what we now just identified is that Minnesota is the state that it's at highest risk for wildfire. The wildfire hazard potential is highest in the state of Minnesota, as opposed to any state that's strictly in the West. So these things are changing very dramatically, and I hope that the pace in which we address it will also continue to increase more dramatically.
Before I jump to Abdul to kind of close this section out, I just want to say thank you, Mish, for the reference to the climate adaptation and resilience plans, and any of the people I've worked with in the past and I'm currently working with. These plans are real. Sustainability.gov. Every agency is doing great things and they need help. There's funding, there are needs, not just tools, services. Go read them. They're on sustainability.gov. I put the link in there. Abdul, thoughts?
Yeah, thank you, Pete. The way I would wrap it up is, let's first of all acknowledge that the way our grid was operated, designed a decade ago, 2 decades ago, 3 decades ago, is not going to be scalable to what challenges we face tomorrow in this transformation. Second, let's try to simplify things a little bit, right? Like every industry we have seen in that has transformed, they have figured out a way to put differences aside and speak in a common language, in a common model, in a common information model. How can we do that in this industry? And how can all the way from policymaking to utilities industries and from generation, transmission, distribution, how can we all adopt that? From a change perspective, I think it's important and imperative to understand that there is going to be an aspect of adoption and readiness. And here's where I think, personally, my opinion is that you got to find the opportunities. If there is an opportunity, and even though you may have a plan for the next 5 years that this is what you're going to do, but if there's an opportunity, you go, you take on that challenge, and you go about doing something about it. Last but not the least, in collaboration, and I think all of my panel peers here have said that more eloquently in different ways, you collaborate, you find the people, you make the connections, and you bring people to the table. You actually go faster by collaborating that way when you get the right representation, the right set of people to the table. It doesn't slow you down. I'm saying that out of doing this, and it has always been faster for me when you have collaborated with the right talent.
Okay, it's 12:58. I'm going to give it back to Mike. I want to just take 30 seconds. I love the common lexicon, the digital literacy that we talked to a lot about, and not easy. You got to learn it, folks. There's no cheat sheet. Seifer, you discussed, bringing people to the table, not easy. And even when it's there, it's when you leave the room, like who's taking lead and so forth. Mish, I love just your spirit. You've built a platform. You probably would love to do a demo proof of concept with so many people. There's folks on this call that hopefully will reach out, because I'm sure your tool can adapt to other situations and other missions. Food and agriculture is another one of our sectors that needs help. Precision farming, precision medicine. And Charles, I mean, you're in this office that's just like the future, right? Where the puck's going. And I love it. And I appreciate your passion, and thank you for all that. So I enjoyed this. I hope our guests enjoyed this. We will continue this dialogue. I hope everybody engages with our community of interest, our working group. Smart cities wasn't thrown around a lot, intelligent cities, but shout out to Michael Dunaway and the NIST folks and the community that I'm working on with Tiffany and others around how are we addressing climate change. It's not a fluffy topic, but something that's real and tangible. So with that, Mike Burkholtz, the floor is yours, buddy.
Good. Thanks, Pete, and thanks to all the panelists who joined today. Very informative conversation. I just want to hit on Abdul's last comment about collaboration, cooperation, the problems that we face in government. And Charles, I mean, you've certainly seen this and are in the middle of it, are very difficult. They require a lot of stakeholders to be involved. And the idea that we bring folks like this together, not just in an act-I-act forum, but also in our day-to-day work, is really important to solve some of the things that are facing our country and our government. So really just want to hit on that collaboration piece, but I do want to thank everybody today for being here. We do have the recording and we will post that up. Hopefully you'll join us for future sessions, but everybody have a great rest of your week. And again, thanks for joining us.
You're the man, Mike. Thank you, pal, for being the co-host.